Okay, what we're going to be looking at in Unit 4 is forces and fields, and what we're really going to focus on is electrical forces and fields. So we're going to look at the difference between what a force and a field is, and the reason that they threw gravitational in here is so that you can look at some of the different types of forces and fields, and you can understand how they're the same and how they're different. Now, the first thing we have to do is we have to look at what the difference is between a force and a field. So let's start with a gravitational force. Forces occur when two objects are having an effect on each other. So let's say we've got the Earth and we've got the Moon. So if we took the mass of the Earth and the mass of the Moon, we took a gravitational constant, which is 6.67 times 10 to the negative 11, and we took the radius between those two objects. Now here's an important point. The radius always has to be measured from the middle of one object to the middle of the other. So when you're doing these calculations, it's the little things that count, like having the proper units, so kilograms, meters, newtons, having the proper constants and formulas that you use. So if we want to know the force of gravity between the Earth and Moon, all we do is put everything in there and we know. So what is a field as opposed to a force? Well, imagine that we wanted to know the field strength of the Earth. What we would do is we'd remove everything around the Earth so it was isolated. No satellites, no moons, no nothing. So all we're doing is looking at the Earth itself. And then let's say we took something from the outside, like a satellite, and put it in and watched what happens. What we're doing here is we're looking at how much of an attractive field the Earth itself has. We're not comparing two things. We're just looking at the Earth. So what we need is that gravitational constant, the mass of the Earth, and the radius of the Earth squared. So at the surface of the Earth, we would get a field strength of 9.8 meters per second squared. Now, if we went 100 kilometers above the Earth, this number would change and go down. So a gravitational field strength is when we want to take a look at one specific thing, like the Moon or the Earth, and see what its pull is. A force is when we take two things and see how they interact on each other. Now, here's the last thing that you have to be able to do in Activity 1 of Unit 4. And this gets a little tricky, so you have to figure out where they're coming from here. What they want you to do is they want you to figure out how high above the Earth a satellite is. For that to happen, we need a formula that does it. So what they're trying to do in this part of the unit is get you to derive a formula that works. So what you should do when you go through here is take a look at the notes. Don't get confused by everything. Just take a look at what they get for an end product. So I'll take you through what they show you, then I'll take you through what an end product looks like. So they say to find how high a satellite is, you need two formulas. You need force of gravity formula, and you need a centripetal force formula. And then what you want to do is you want to isolate the r. So you'd bring this r squared over here, you'd get r cubed. You would take the t squared and you would put it up here. You've got a mass you've got to move around. You got to cube root everything. So what you're going to have to do is you're going to have to go through all of that, decipher this through the content, find their final formula that they use for radius. Once you get your answer for radius, you need a second formula. The height that the satellite is above the Earth is going to be your answer from r up here, and then you're going to subtract the radius of Earth in meters. So you're going to have to look that up. So whatever you get for an answer from equation 1, you are going to have to stick that answer here and subtract the radius of the Earth, and that will give you the height of the satellite. Once again, don't get confused when they start with this. They will take you through the derivation so that you get this formula down to r. You'll know it when you see it because you'll see a cube root on the other side. That's the formula that you use. This is for people who want to see how formulas are derived in physics. Now, in the second one where you're looking at velocity, I show you the derived formula right here. So what you do is you start with a formula for force in centripetal force, and you start with a different formula for centripetal force. You marry them together and you come up with V equals 2 pi r over period. Don't forget, the period for many things to go around Earth is 24 hours. This has to be in seconds. That would be 3,600 seconds. So use that unless they give you a different period as you're going through these problems. Okay, U4A1 is a 5-mark quiz that you have to do. So let's just quickly review the 4 things you need from U4A1. You have to understand the force of gravity formula. You have to understand the field strength formula and how field strength is different from force of gravity. You have to be able to follow the deriving of a formula. You only have to be able to use that formula on a test, and you'll have to know how this formula here works with this formula here to get the height of the satellite above the Earth, and you'll have to be able to use this formula here to get the velocity of satellite.